Hello, today we will learn about number systems. So numbers, there are all kinds of numbers. So I will make a list of numbers right here. So negative 3.4, 2, square root of 2, negative square root of 9, what else? 0, 1. So all of these are numbers. Oh, let me add another one. 5, 6. All of these are numbers. However, a number system may not contain all of them. So a number system is a collection of numbers that have the same property, and thus they can be put together in a numbering system, and because they have the same they share a characteristic, and so they are given a name. So whole numbers are ranging from 1 to infinity without decimals. So it's 1, 2, 3, 4, so on and so forth until infinity. Natural numbers are 0, 1, 2, 3, 4, all the way to infinity. So it's basically whole numbers plus the 0, because the 0, as you might have noticed, is not included in the whole numbers, but it is included in the natural numbers. An interesting fact is that actually 0 was not part of the natural numbers until the 19th century. So until the 19th century, actually whole numbers and natural numbers were the same thing. Well, enough history. Now let's go to integers. Integers range from negative infinity to infinity, but also without decimals. So it's negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on and so forth. So just keep extending to the left and to the right. So as you might see here, it's actually negative numbers plus the natural numbers. And now rational numbers. Rational numbers are numbers that can be represented by a over b, so by a fraction, where a is an integer and b is an integer too. So the ratio of two integers. However, something to keep in mind is that, for example, negative 3 could be represented as negative 9 over 3. Both negative 9 and 3 are integers, so an integer is also a rational number. So rational numbers are fractions. Let me erase this to have enough space. So rational numbers are fractions or decimals, however you want to look at it. But the decimals must be repeating and finite. No, repeating, just repeating, not finite. I'm sorry, just repeating. So rational numbers are fractions or decimals, but the decimals must be repeating. They must have a pattern, and integers. So that's what rationals include. So as you might see here, rationals include integers, and integers include natural numbers, and natural numbers include whole numbers. So actually the rational numbers in this list is the biggest set. They contain the most numbers. Integers are the second biggest, natural are the third biggest or second smallest, as you want to see it, and the whole numbers are the smallest. And so if a number is a whole number, it is also a natural number, an integer, and a rational number. If a number is a natural number, it is also an integer and a rational number. So any number that is in any of the sets is also included in every set underneath it. Only the ones underneath, not the ones above, or not necessarily. But now let's look at irrational numbers. So irrational numbers are kind of the opposite to rational numbers. They are numbers with decimals, but decimals that are not repeating, thus they cannot be represented as the fraction of two integers. The most well-known example of an irrational number is actually pi. Pi, as you might know, is 3.14159, and it continues on and on and on forever with no repetition, no pattern, and so it cannot be represented as a over b. There is no a and no b that can represent pi. So now we had a list right here, and let's see what they are part of. So this is a rational number. Why? Because it has a decimal. So we know it cannot be either integer, natural number, or whole number. Also, the negative sign tells you that it for sure cannot be a whole number or a natural number. Now, since we only have 0.4, it doesn't go on forever, and you can see kind of a pattern, and the pattern is that you only have 0.4, and so it is a rational number. It could easily be represented by 34 over 10, negative 34 over 10. A2 is a whole number, so since it's a whole number, you know that it is also an integer, a natural number, and a rational. The square root of 2, if you plug it in your calculator, you will find that the decimal goes on forever and ever, and there's no logical pattern, no repetition, and so it is an irrational. Something to keep in mind that makes it very easy to remember is that all the square roots of positive numbers that are not perfect squares are irrational numbers. This is something very important to remember, which will become very useful later on. And so you will see what I mean by perfect squares in the next video.